Hi, this is Reverb Audio, and today I'm talking about filament transformer voltage. So I'm holding in my hands a filament transformer, and in your vacuum tube amplifiers, preamplifiers, and phono stages, you may have these guys, or you simply may have your filament supply as part of your main power transformer. So what happening here is might be a shared duty production from your main transformer. But if you see an extra filament transformer, which might be the size of this baby, or it can be something much larger, there are filament transformers this big, just humongous. That was actually not a filament transformer, but I have filament transformers which are of that size that I just showed you. So the role of these is to provide filament voltage, but my video now is really about how to make sure that your vacuum tubes are getting the filament voltage, the specific voltage that they need. And this video is specifically for the Darling amplifiers, and here we go. So where you when you look up the 6J4, that's the tube, that's the driver tube for the Darling amplifier. And for the 6J4, and not just the 6J4, but any of the 6J4 family members, so these tubes, like the 8532 is a direct substitute, and it's a better version. Basically, that's the US military version of the pedestrian 6J4. When you look up the data sheet, you will find that here's the filament voltage, 6.3 volts at 0.4 amps. Right? It says heater voltage and heater current. So basically, we need, I think I need to zoom out a bit to see more. So we need 0.6, sorry what I'm writing, 6.3 volts AC at 0.4 amp current per tube. And we have two tubes, one per channel, so we need a total of 0.8 amp, right? So we need 6.3 volts at 0.8 amps. So now here's the deal. You are buying a filament transformer for the Darling amp, and that filament transformer says that it will give you 6.3 volts, right? That's how it's specified when you purchase it. And now you might be very much surprised that when you build the amplifier, there's a negligible likelihood that you are going to get exactly 6.3 volts. You might be getting something very, very different from that. And why is that? The main reason for that is that all the filament transformers, when you buy them, they have a specification for it. And the specification is for the primary winding and for the secondary winding. For the primary, it means that that's the source. And what is the source? It might read 120 volts AC, right? Or if you are in Europe, 240 volts AC. And now, the second, that's easy. You just go for whichever is in your country. But even if you choose the right one, let's say you are in the US and you choose the 120 volts AC, you still might not get the exact voltage for your secondary, because in your line, maybe you are getting 117 volts, or maybe 128 volts, or maybe just 100 or 5 volts. That totally depends on your local power company, how tightly they keep the voltage and what is the voltage you are experiencing it. I would say normally, generally in the United States, the voltages are at least 120 volts, and unless you live in an area that was recently developed and it's totally overpopulated. So it means that the power grid is overloaded, then you might see voltages sagging down to 105 volts AC. So if you live here in Hawaii and you remember Stu's audio shop, audio directions, his stereo shop at the Algaroba Street, there the line voltage measured 105 volts AC for him. So it sagged that much, and that's basically the middle of Honolulu, and that's how sucky the voltage was there. And but for example, at most places where I lived here in Honolulu and in Hawaii, the voltages now tend to be 120 volts. So now I'm basically measuring almost always 121 volts AC. But it might depend on the day, on the time when you are measuring it. So maybe late night you might be measuring 125 volts AC, and then during the time like 6 p.m., 7 p.m. when everyone's at home watching TV, doing their laundries, everything, then it might drop to 110 volts AC. So it's very important that when you want to optimize your filament supply of your power amplifier or preamp or anything else, you have to measure what's the voltage that you are getting at your home. So you don't want to think about an ideal 120 volts AC, you want to think about the exact AC that you are getting. And if you have this situation that sometimes you have 125, sometimes you have 110, then use the highest voltage that you regularly measure as your baseline, so that will be the basis of your calculations. And I tell you why later on. So basically, if you are measuring regularly 125 volts in your line, then take it as a baseline that in your wall there's 125 volts AC coming out, okay? And now if the voltage is higher and your transformer is specified to 120 volts, then of course the secondary voltage will be higher as well. However, there is one more factor that's going to impact the voltage, the secondary voltage that you are getting for your transformer, and that is the load, that how much current you are drawing from your transformer. And when you look at your transformer specification, it will specify the secondary at a specific voltage, let's say 6.3 volts AC, at, let's say, 2 amps. And if it says CT, it means that the secondary is center tap, which means that, let's show here, this is the secondary voltage. So it has 2 wires coming out, and the difference between the two, that's 6.3 volts AC. And if it shows CT, it means center tap. So it means that there's a third wire coming out, which is at the exact middle. So you are getting 3.15 volts between here, 3.15 volts AC, and then 3.15 volts AC between those two. So then you have to take those 2 outer wires to get the 6.3 volts out of it. So now let's say that your secondary is specified for 6.3 volts at 2 amperes. So this means that your transformer will feed 6.3 volts exactly in case you are drawing exactly 2 amps of current, and your primary voltage is specified exactly what the transformer datasheet says. So if the transformer datasheet says 120 volts AC, 120 volts AC, then that's when you are going to get 6.3 volts, when the primary is exactly 110 and you are drawing exactly 2 amps. So now what will happen to you in real life is that if you are using this power transformer in the case of the Darling amplifier to feed your two 6J4 driver tubes, it means you are drawing 0.8 amps of total current from your transformer. That is much less than the 2 amps. So it means that when you draw less than the rated current, the voltage will go higher. So you will measure probably something like 6.5 to 6.8 volts AC because you are drawing much less current. Now, if you have a 2 amp rated transformer and you are trying to draw, let's say, 3 amps out of it, then you will be getting maybe like 5.7 volts. And of course, you have a good chance that you will burn down your transformer. You are going to have equipment failure on your hands because you are drawing more current than rated. So as a general practice, always use a secondary transformer that has at least an equal rating to what you are drawing or higher. And my recommendation is go much higher. So it means that, for example, in this case, we are drawing 0.8 amps and your transformer can provide 2 amps. You are good because it can provide basically 2.5 times as much current as you are needing. So you are not pressing that transformer. Your transformer will have a lot of headroom. So basically you allow that transformer to work at a very comfortable pace. And I'm not telling you what's the advantage of that because then this video will be never ending. So right now I want to focus on what happens when you open up your amplifier and you read the filament voltage, and the filament voltage is not what you are supposed to read, not 6.3 volts, but something else, how you can fix it to measure 6.3 volts. And this is what you need to do. So let's just divide it here. Let's continue on this little piece. So basically, let's say that you have built your Darling amplifier, and instead of that 6.3 volts, you are measuring 7.1 volts AC. Okay? So now this is what you have measured. Now, what you need to do is add a resistor in series with the primary of your filament transformer to drop extra voltage. So this voltage goes down from 7.1 volts to 6.3 volts. And why we need that? We need that because if you run it at 7.1, then you will be aging your driver tubes and they will die in under less a year of operation instead of lasting a lifetime for you. So basically, vacuum tubes need to be operated at the exact voltage where they are specified. And as you read in the datasheet, plus minus 10% is okay. And the situation is much more complex, but for the Darling amplifier, you want to read a voltage between 6.1 volts AC to 6.35 volts AC. So if you have built your Darling amp and you are reading a voltage in the case of this 6J4 driver tube between those two values, then do not worry, you get it down fine. But if you read much higher than that, you read like 6.5, 6.7, whatever or higher, then you need to do what I am suggesting now to do. So basically, you are getting 7.1 volts and you need 6.3. Now you subtract 6.3 from 7.1, so 7.1 minus 6.3 equals 0.8. So basically the difference is 0.8 volts. So you are getting 0.8 volts higher filament than necessary. And what if we wanted, let's say that here is your vacuum tube, that's the filament drawing for the vacuum tube, and you are connecting it to the secondary of the power transformer, and that's fed by the primary of the power transformer. So here, this is your 120 volts AC power line, and this is here your vacuum tube, right? And now here we measure the 7.1 volts AC. And now the difference between what we want to have, the 6.3, and what we have 7.1, the difference is 0.8 volts. And the current at which we are drawing it is 0.8 amps. Actually, it's not exactly the same, because when you run it hotter, it draws more current. But for simplicity's sake, because current is harder to measure, let's just use that 0.8 amps value for calculations. So basically, we need to calculate the resistance that we would need to insert here between the secondary winding and your filament, right? So if we put a resistor, let's call it R1, so the value of R1 equals this difference, 0.8 volts, divided by the current, 0.8 amps, that the two tubes draw. So that equals 1 ohm, 0.8 divided by 0.81. So here, if you put a 1 ohm resistor here, then it will fix your filament voltage, and you will have 6.3 volts. And this is one thing that you can do if you measured 7.1 volts for your Darling amps input tubes. You put here a 1 ohm resistor, and it fixes the problem. However, what happens here, that if you put the resistance there, then you still get that extra current draw and extra duty on your filament transformer. So instead of putting the resistor here on the secondary side, if you put it on the primary side here, in this case, your transformer has an easier job to do. So you are pressuring that transformer to work less. So in this case, for the transformer that I recommended for your Darling amp, you have plenty of headroom, so you might stick a resistor, a low value resistor here on the secondary. It's not such a biggie, it doesn't really matter. But if you have a commercial amplifier, for the commercial amplifiers, they have filament transformers where the filament transformer is rated just enough to handle your vacuum tubes, and in that case I would say it's mandatory to put the resistor on the primary winding instead of the secondary, because you need to give the headroom for your transformer. It will mean that your transformer will run cooler if you put the resistor in series on the primary instead of putting it on the secondary. If you put it on the secondary, the transformer will see the same load as if there's no resistor there. However, if you put it here on the primary, if you put a 1 ohm resistor there, it's going to do nothing. And why? It's because here you have a low voltage high current situation, and there you have high voltage low current situation. So what you need to do is take that voltage that you measure on your primary, so which was the 7.1 volts AC, right? So you need to take it as the calculation. So this is your secondary voltage, right? 7.1 volt. And you need to measure what is your actual line voltage. Let's say you have measured 125 volts AC, right? This is what you measured. It's nominally 120, so that's what it's supposed to be. But you don't care what it's supposed to be. You need to care what it is actually to fix your situation instead of an imaginary situation. So you take 125 volts and divide it by 7.1. Let's calculate what that is. Let's get a calculator. 7.1. Wait. 125 divides 7.1, and that's, yeah, here we go, that's 17.6. So basically it means that there's a voltage difference of 17.6, so a step down. So it's a 7, where do I have space left? Here, 17.6 to 1 step down. That's what the filament transformers ratio is working for your load in your case. So that's what we are getting. So what you need to do is that instead of 1 ohm resistor, you need to square that step down ratio. So you need to get the square of that value. Where is it? Here. And that's 309.9. So basically 310. So you need to multiply the value of R1 times the step up ratio, let's call it SR, that's 17.6, that's the step up ratio, square it. And that's the value of this, let's call it R2 resistor. So basically here we have 1 ohm and the square of the step up was 310. So you need a 310 ohm resistor to put here in series with your primary to drop down that voltage to 6.3 volts that you need. And basically that's it. And then if you use this calculation, so you measure what should be the resistor that goes on the secondary. That's easy to measure. You take what's the voltage that you need to drop from your actual voltage to what your tube needs, divide it by the current demand, and then you get the value of the resistor in ohms that you need to put here. Now multiply that value by the turns ratio of the transformer on the square. So square it, and that's when you get the and multiply that by the value of the resistor you would place here at the secondary, and then you get the resistor to place on the primary. Important, you either place it here or here. Don't place it at both places at the same time, okay? Because then you are going to drop double the voltage. So this is how you calculate the value. And second thing that's important is to calculate the current. And the current here in this case it's 0.8 volts times 0.8 amps, right? That's 0.64 watt. So that's the wattage you need to drop. So now usually good practice when you are dealing with filaments is that you need to multiply this by 5. And so 0.64 times 5, you need roughly a 3-4 watt power resistor, 3 watts to 5 watts. So this value is exactly 3.2. So you need a 3.2 watt resistor. And when you look at power resistors, then you have like 3 watt values and 5 watt values in general. And I would recommend get like a 5 watt rated resistor, so to make sure it runs nice and cool, and use that here. If you put it on the primary, there it will see 120 volts. So there you need, I would always put something that's much more serious wattage than what's recommended, just because it sees 120 volts. So whenever you turn on your amplifier, that resistor is going to see 120 volts AC running across it. When you put it on the secondary, so it's that 1 ohm resistor case, then it's going to see only 6.3 volts. That's nothing, piece of cake. But when you are subject to 120 volts, now that's much more severe. So I would recommend using like at least like a 15-watt resistor or higher when you put it on the primary. And there are chassis mount resistors, like those nice Dale resistors. I like to use them for this purpose. So basically you can just mount them on the chassis, and it's nice and safe and secure. So thank you everyone for tuning in. I hope this helped everyone. This is very important, and you need to do this for all of your filaments in your darling amplifier. Make sure that your 6J4s or 6J4 equivalents run at the proper voltage. Make sure your power tubes run at the proper voltage, and if you are building one where you use a tube rectifier, your tube rectifier should also run at its proper filament voltage, and you can use these measurements, this system, to adjust the voltage if necessary. So this is why I did not include this in the original schematics, because it depends on your case. It's different for each of you depending on what parts you get and what part of the world you are. Even if, for example, here where I live, if I would move like a couple of blocks down, I would need a different optimal filament voltage compared to what I am using now. So it's a good idea to always double check what voltage your tubes are ticking at, because if you don't do that, then you risk shortening the life of your vacuum tubes by a very, very large margin. And you might be getting, let's say, 1,000 hours out of them instead of 10,000 hours. And of course, needless to say, do these modifications, do these things only if you are trained, you are certified, you are an electrician. Don't just go on about checking the voltage in your home, whether you have 125 or 122 or whatever. Especially if you are a kid, you must not just poke around in your power system. I absolutely forbid it. Do not do that. Get an electrician and have him measure the voltage in your home, okay? Everyone practice safe practices. Your life is the most important. These are lethal voltages. These are not toys. So thank you for tuning in. Have a fantastic day. Enjoy your tube amplifiers for a very, very long time. Bye bye.